Okay, we are going to start here on this one. Okay, so this is a relay, which means you got to make sure that your answer is right before you move on. To do these, and all this is simplifying into one single term, I need to be able to substitute some stuff in or, change things up a little bit legally, which all comes from that fluorescent green paper that you have, right? This is what you need in front of you. Don't be staring at me. This is where your stuff is coming from. There's no magic involved. So this cotangent that's on the outside here, we could distribute it in, but it's not going to really do anything for me when I do that right now. So maybe I want to go ahead and change some things. So what can I change cotangent to? Okay, I can make it 1 over tangent, and sometimes the 1 over tangent might actually help. Like if there was tangents in here, then it would cancel out. But what could I change it to as a quotient? It's a quotient for cotangent. It's cosine over sine, yeah. So cotangent is cosine x over sine x. Okay, so since I put that in terms of sine and cosine, maybe I want to go ahead and make this into a sine or cosine type of thing. So what can I substitute in for secant? 1 over cosine. So this can be 1 over cosine x and then minus cosine x. Everybody with me so far? So then can I cancel these cosines out right here? These, can I go like, no, that's a big fat no, right? So if I cancel this out here, does this just gone? No, because you're going to have to distribute, so you got to be careful. Maybe I'll write in one extra step that you might not necessarily write, but when I distribute this is going to give me in the numerator cosine times 1 is cosine, right? In the denominator, I get sine of x times the cosine of x, right? Minus, and then when I distribute this over here, this is like over 1. So I get cosine squared x over sine x. Everybody with me? So can I cancel these cosines out? These two right here? You can here. In this one fraction right here, do you see how there's no addition or subtraction at all? So these things are being multiplied. I can totally cancel those out. Am I just left with sine of x right there? No. It's 1 over sine x, right? But then this is minus cosine squared, bless you, over sine. Well, I have a common denominator, right? So can't I just make that all over sine of x since they're the same? And this would be 1 minus cosine squared x. So what can I substitute for 1 minus cosine squared x? Sine squared x. So this gives me sine squared x over sine of x. Then what happens? It'd just be sine of x. These are going to cancel out, and I'm just left with the sine of x. Everybody good so far? Yes? So what do I do with sine of x? I put it right here. Right. So if you get it wrong, that's a problem, right? Okay. So now, got to figure out what to do here. So I can make cotangent into a quotient. I can also make cosecant into a reciprocal, because if there's nothing squared there, like I can't replace this with anything that has to do with cosecant, because the cosecant cotangent relationship happens when they're squared, right? That's the Pythagorean ones. So I'm going to leave cotangent for a minute in the numerator just so there's not so much to rewrite. And let's make cosecant into, that would end up being 1 over what? Sine. So I'm going to have cotangent of x over, and then 1 over sine x minus sine x. Can I cancel those signs out? No, I cannot. But in the denominator, I need a common denominator, right? What would my common denominator be? Sine, okay? So I'm going to put this over 1. I'm going to leave cotangent of x in the numerator, right? So in the denominator, I'm going to get a common denominator of sine of x. Since this already has a sine x in the denominator, that stays 1. This would have to be multiplied by sine over sine, so it ends up being 1 minus sine squared x. Everybody with me on that? I just went ahead and put it together instead of doing it separately and then putting it together. can I substitute something for 1 minus sine squared? Cosine squared. So now this is going to give me cotangent x over cosine squared x over sine of x. Everybody with me so far? Can I make cotangent into a quotient? What is cotangent as a quotient? Cosine over sine. So cosine of x over sine of x. And it's going to be divided by that cosine squared over sine. But dividing by that is the same as multiplying by the reciprocal, right? So I'm actually going to multiply by the sine of x over cosine squared x. There is no addition or subtraction anywhere. These two things are being multiplied, and that's it. So that means I can reduce some stuff. I can knock these signs out. This cosine knocks out one of these, so I'm left with 1 over cosine x. But you can't leave it as a reciprocal, so what's 1 over cosine x? Secant x. And so then you put secant in here, and then you move on. Okay. Everybody good? Pay attention, because now when you go, after you go here, you don't come back over here. Mrs. Archer and I both did that. We were like, I can't get the answer. Can you? No, we were doing some crazy stuff. Follow not only the alphabetical letters, but the big black arrows. Okay, make sure you're going this way because we both missed that. You only have to go to F. You can stop at F. You can keep going if you want to, but you just have to get yourself to F. Okay? We good? But not right now, because we're going to do 2 on the back, and then we need to move on to the notes. But I want you to think back through that. So look on the back. We're going to change something first down here at the bottom. So find this part right here. You see where it says start? And then there's a pi right here. This should be a negative pi. Because there's 2 pi's coming off of that same one right there. All right, so let's look at the start. We want the sine inverse of the cosine of pi thirds. So what is the cosine of pi thirds? Y'all agree with that? Cosine of pi thirds is 1/2. So then what I want is the sine inverse of 1/2. Whether you write that part down or not, that's up to you, but that's what we're doing, right? So the sine inverse then of 1/2 is what? Pi 6. So there's these coming off of here. Since it's pi 6, I'm moving this way. Make sense? So then I want the arc cosine of the tangent of 3 pi fourths. So that means I'm going to want the arc cosine of, all right, so what's the tangent of 3 pi, or what's the tangent of pi fourths? 1. And then 3 pi fourths is in which quadrant? Second. And is tangent positive or negative in the second quadrant? Negative. So it's the arc cosine of -1. So what angle gives me a cosine value of -1? Pi. So then my answer is pi. And then you move on to the next one. Okay? You have a question? Why it's pi? Cosine is your x value. So when you're thinking about the unit circle, when x is -1, you're there at pi. Okay, does that make sense? Thank you. All right. So go now. All right, anybody, go right now because it says very important. All right, we all good on that? Okay, so then let's go ahead and get started on the notes. Okay, this is going on page 115. Okay. So we have 115, there you go. We have simplified the identities. Today we're going to prove them, which is actually easier, I think, because when you're simplifying them, you don't know what your goal is. When you're proving them, you know what your goal is, so you know you're going in the right direction and when you're done. So it says proving or verifying, that can be called 2 different things. Hang on, weird things happen. So proving or verifying an identity means to show that both sides of the equation are the same. So to prove an identity, you simplify one side. That's the key. You're only working with one side of the equation until it is equal to the other side. So how do you know where to start? Here's this hint that's very, very important. It says work with the side that looks more complicated. So it's kind of a matter of opinion, but basically it's easier to get the more complicated looking one into something simpler than the other way, because then you have to kind of guess at what to put in. So if we look at number 1, Would you say that the left-hand side definitely looks more complicated? Yes, okay. So we're going to start with the left-hand side. Our goal is the right-hand side. Okay, so that's what we're trying to get it to. And so I need to start by basically simplifying like we did before. Okay, so cosecant, I've got cosecant sine and cosine squared. I could substitute something for cosine squared, but that introduces two terms. I don't know that I want to do that. But we'll take this cosecant and make it into what? 1 over sine? Okay. So basically, if this is going to be 1 over sine theta times cosine squared theta plus sine theta equals cosecant theta. You have to write that right-hand side down every single time. If you don't, you're going to get lost and confused in things. And you have to remind yourself, you are not trying to solve anything. There's no moving things from one side to the other, nothing like that. Now, I kind of wrote an extra step in here. You wouldn't have had to write it like this, because basically, isn't this going to become cosine squared over sine? So it would have been fine just to write that there, okay? But just in your notes, sometimes I write little extra things so you know where it's coming from. So now I have cosine squared theta over sine theta plus sine theta equals cosecant theta. So if I have two terms and one of them is a fraction, or even if both of them are a fraction, combining them into one term would be a good thing. In order for me to do that, I have to have a common denominator, right? This denominator basically is 1. What would my common denominator be? Sine. So it's going to be sine in the end. So this first one already has sine, so it's just cosine squared. And then the sine theta would have to be multiplied by sine over sine. So this will give me 1 plus sine squared theta equals cosecant theta. Everybody with me so far? Stop me if I lose you somewhere. All right, so now this cosine squared plus sine squared, does that look familiar? It equals 1, right? So I get 1 over sine theta equals cosecant theta. And what's 1 over sine theta? Cosecant theta. So cosecant theta equals cosecant theta, and you are done. It's a proof or a verifying, so that's what you should get. Like, you already know what it's supposed to look like. Okay. Everybody good so far? Any questions? All right, so let's look at number 2. Which side do you think looks more complicated? Left side? Okay, it's a matter of opinion, but I will tell you this. If you have one side that's a fraction and one side that's not, use the fraction side, because it's easier to get stuff out of a fraction than to get it back into a fraction when you're trying to figure out what to substitute in. So we are going to work with the left-hand side, and then we are going to make this our goal. Right? So what do you think we could start by doing with that left-hand side? Okay. Because since I don't have any of the reciprocal ones, I don't know that making anything to a reciprocal necessarily makes any sense. But since I have that sine squared y, I can make that into that 1 minus cosine squared. Does that make sense? If you've got something that you can substitute, and again, I'm not making this stuff up off the top of my head. It's coming from this, right? So instead of sine squared y, I'm going to have 1 minus cosine squared y over cosine y equals then secant y minus cosine y. So then what do you think I could do with the left-hand side? Can I just cancel the cosines out? Is that legal? Like, can I cancel this cosine out and make that just 1 minus cosine then? No, because there's a subtraction. Be very careful, okay? Because that's where you start making up math, right? But if you want to be able to do that, what can you do with that fraction? If you do have addition or subtraction in the numerator, you can split it, okay? It could multiply by some, I mean, those are options too. But not if I have it in the denominator, then no. But if the numerator has more than one term in it, you can split the fraction into 2. Just like we took these 2 fractions and put it into 1, I could take the 1 and put it back into 2. So I can make this into 1 over cosine y minus cosine squared y over cosine y equals secant y minus cosine y. So look at that, make sure, remember we did that when we started simplifying, but I know it's been a week since your brain has had to think about this. But do you understand what I did and why that's legal? Because I could put it, now they have a common denominator, I could put them back together, but I just took them apart, so I don't want to do that. What is 1 over cosine y? Secant y. And then now can I cancel cosine here? Yes, now this can be canceled with one of those, so I get secant y minus cosine y. And guess what that equals? Secant y minus cosine y. Then we're done. These are kind of fun. They're like little puzzles, okay? Ask me questions if you have them. Don't just sit there and be silent because nobody else is saying anything, okay? Yeah, I didn't realize, well, it was on your notes. I didn't realize you didn't have this. I would have sworn I sent it. I'm sorry. All right, let's look at number 3. Which side do you think looks more complicated? On the right side. I mean, I think we can all agree with that, right? So our goal is the left-hand side. Now let's think about some of the options that we have here. What's one option we have? Okay, well, if I'm going to combine everything, I could only do that like if it was a fraction and I could get a common denominator, or if they were actually like terms. So I can't actually combine the right-hand side any more than it's combined. Okay, I could turn cosecant into 1 over sine. Would that work? Okay, that's one option. What's another option? How many terms do I have? You only have 2. This is a term, and this is a term. Your terms are separated by addition and subtraction, okay? So I have a GCF. So I could factor out a GCF, or I could change that cosecant to a reciprocal, right? Either one. So, and now I want you to look at number 5. Do you see how number 5 is pretty much set up the same way? Okay, so we're going to do one way and one the other way. So you can see that, and it doesn't matter, like I could do this by doing the reciprocal thing, you could do it by factoring out, and we get the same thing in the end. So we'll do one of these. The first thing I heard was reciprocal. So we'll do this one reciprocal, and we'll do this one by factoring, just so you can see the differences. All right, so I'm going to make this into cosine squared alpha equals, this would be sine squared alpha, and then cosecant is 1 over sine, so this would be over sine squared alpha minus sine squared alpha. Everybody with me? So left-hand side I rewrite again, that's just cosine squared alpha. Well, what's sine squared over sine squared? 1. Isn't this fraction just 1? You got the same thing in the numerator and the denominator? So I get 1 minus sine squared alpha. What's 1 minus sine squared? Cosine squared. So you got cosine squared alpha equals cosine squared alpha, and you're done. Okay. Everybody good? All right, let's look at number 5 then. So instead of using the reciprocal, because I could make sine into 1 over cosecant, but instead of doing that, we're going to do this one by factoring. So the left-hand side is cotangent squared theta. So my GCF is cosecant squared, right? So I'm going to factor out that cosecant squared theta. That leaves me with what? 1 minus sine squared theta. Don't forget about that 1, because when you factor out a GCF, from this step to go backwards, I'd have to be able to distribute this back in and get the same thing back, right? And sometimes we forget about that 1 that's in there. Everybody good so far? Yes? All right, so this gives me cotangent squared theta equals, well, what is 1 minus sine squared? Cosine squared. So this gives me cosecant squared theta times cosine squared theta. So I'm going to rewrite cotangent squared theta. And then what could I replace cosecant with? 1 over sine. So this becomes cosine squared theta over sine squared theta. And then what's cosine squared over sine squared? Cotangent squared. So cotangent squared theta equals cotangent squared theta, and you are done. Okay, everybody good? Ask me questions if I lost you somewhere. Did I lose you? You've got this look of despair. Ask me a question if you got a question. Where did I lose you? This right here? Okay, because cosecant became 1 over sine and then cosine. Okay, you good now? Yeah? Okay, everybody else good? Yes? All right, so let's go back up and look at number 4. So on number 4, I could start by distributing, but that's really not going to be maybe the best thing that I do here, but it is one option. Another option is to take those two fractions and go ahead and make it into 1. So that's where we're going to start, okay? So I'm going to leave this tangent of x on the outside. Then on the inside, I'm going to get a common denominator. What's my common denominator going to be? Yeah, tangent x times secant x, because you just multiply them together. So tangent x times secant x. Which means that this fraction right here would have had to have been multiplied by secant over secant. So that would give me secant squared minus, and then this one has to be multiplied by tangent over tangent to get a tangent in the denominator. So this is going to be tangent squared x equals cosine x. Okay. Everybody with me so far? Because, okay, so this fraction right here has to be multiplied by secant over secant because to get the common denominator. So it's kind of like if I had 1/2 plus 1/3, right? I have to multiply this one by 3 over 3, and I have to multiply this one by 2 over 2, right? So that's what I'm doing there. The difference is I have secant x over tangent x minus tangent x over secant x. And so in order for my common denominator to end up being secant times tangent, this one has to be multiplied by secant over secant, right? That's how I get that out of it. And this one has to be multiplied by tangent over tangent. And that's how I get that out of it. So this becomes tangent squared, and this becomes secant squared. And yeah, does that help? Okay, I kind of just skipped the step of having two separate fractions, just because you can do it separately, then put them together. But does that make sense? We good? That's why I said fractions. I mean, I know y'all try and avoid them, but you can't. And if you're always like on this, sure, calculator can help you with that. Calculator ain't going to help you with that. Like, you got to know what to do. All right, so everybody with me now? Okay, so now I've got some squared and maybe some Pythagorean stuff going on there. Can I substitute anything in that numerator? What's secant squared minus tangent squared? 1. Because tangent squared plus 1 is secant squared, so that's just 1. So now I just get tangent of x times 1 over tangent x secant x equals cosine x. So now when I actually multiply tangent times that 1 over tangent x secant x, what happens? There's no addition and subtraction left, right? Put that over 1. Now you can actually multiply and rewrite it as tangent over tangent x secant x, but you don't need to, because don't these just cancel out? Yes? And you get 1 over secant x. Yes. So 1 over secant x equals cosine x. So cosine x equals cosine x, and you're done. Okay, everybody good so far? Any questions at all? Okay. Well, let's look on the back here at number 7. We're going to skip number 6. So which side looks more complicated to you? The right side, okay? So I would say we're going to start here and make this our goal. So I'm going to give you a minute to get started on that and see what you can get done with that, okay? and then we'll talk about it as we go through it together. Because remember, they can be different and still both be okay. So if yours doesn't match what I'm doing right here, then just maybe rewrite it over here as a different way to do it and don't like scribble out what you have. Because a lot of you went and started doing some reciprocal stuff, which is fine. Because there's, like I said, there's more than one way to do it. But let's look at what I would do to start this one here. Even though cosecant and cotangent a lot of times is like screaming, put in the reciprocals and the quotients. If there's squares in there, then maybe I have some Pythagorean identities I can use. So let me just go ahead and rewrite the left-hand side. 1 plus sine squared theta equals, all right, so this doesn't match anything directly on what's actually printed on there, right? But this does. What's 1 plus cotangent squared? Cosecant. So I'm going to leave the numerator as 1 plus cosecant squared theta right now over cosecant squared theta. Okay? That's one option. Now, at this point, I could do some reciprocal stuff, right? But I'm not going to just yet. Everybody okay with where everything came from? Now I'm going to take this fraction and I'm going to split it. So I'm going to get 1 plus sine squared theta equals 1 over cosecant squared theta plus cosecant squared theta over cosecant squared theta. Yes? These cancel out, right? That's going to leave me with 1. And what's 1 over cosecant? Sine. So this is 1 plus sine squared theta equals 1 plus sine squared theta, and I'm done. That's okay. And then I'm going to work it a different way as well, because I just want you to see that there's other options out there. And I'll do some of the reciprocal stuff that y'all did. So I'm going to start with 1 plus sine squared theta equals. All right, so I saw a lot of I did see some of you do cosecant squared down here, but then you made this into 1 plus 1 over sine theta, which is fine. Okay, there's nothing wrong with that. Then I've got 1 plus sine squared theta equals, well, this would really be 1 plus 1 over sine theta over 1 over sine squared theta. Would you agree with that? Okay. So let me ask you this then. When, oh, I sure did. Thank you. I forgot it right there. Thank you. And I meant to ask you this back here. Right here, is it legal just to cancel these cosecants? That's a big fat no. Don't do things like that, okay? So now here, I could go ahead and multiply by the reciprocal. But I didn't want to do that when I had two terms. If I have one big fraction down here, if you left it like this, you can get a common denominator and then do that. But I have one big old term here. So I'm going to make this into 1 plus sine squared theta equals 1 plus 1 over sine theta. That's my numerator, right? Sine squared theta. I don't know why I can't write that. And then I'm going to multiply that by sine squared theta over 1 because I'm multiplying by the reciprocal. You with me? So now when I distribute, and I've got 1 plus sine squared theta on the left, when I multiply this times 1, that gives me sine squared theta, right? And when I multiply this by this, what do I get? 1. And you still get the same thing. Okay? So you get the same thing in the end either way. Now, you might be thinking that, ooh, I like one better than the other. But honestly, it's going to be whatever you think of at that point. Just know that you just got to keep plugging through. And if you feel like it got way too complicated, maybe you complicated it when it didn't need to be complicated. And if you made this as 1 over sine theta and then this into cosine over sine, that's fine too. If you could get common denominators and do all kinds of stuff with that and still get to the same part in the end. Okay? Any questions at all? Okay. All right. No questions at all? All right, so I'm going to stop here for today. What I want you to do in the 10 minutes that are left is work on that yellow one on the side where this stuff is, not the other side. That way you can start thinking through substituting things. And because we're going to finish this up tomorrow, and then I'm going to give you an assignment like this. So start on the relay side, work on that so that you can get some questions answered.